Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, or TuneIn Radio, or you can add our RSS feed to your podcatcher of choice. You can also follow us on Twitter, we're Podcast_init, or Google+, with links in the show notes. And please give us feedback. You can leave us a review on iTunes, send us a tweet, send us an email, or leave us a message on Google+. Providing feedback helps us get found by other people so that other people can enjoy the show as much as you. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. We're recording today on August 27th, 2015, and your hosts as usual are Tobias Macy and Chris Patty. Today we're interviewing Paul Tagliamonte, Tuukka Turto, and Morten Linderud. We're talking to them about Hylang. So, could you please introduce yourselves?
Yeah, so I'll go first. My name is Paul Tagliamonte. I go by Paul Tag online. I'm on the board of directors of the open source initiative, the OSI. I'm a Debian developer involved with a couple of random things. Been a long time Ubuntu member and one of the original authors of Hi.
Yeah, I'm Tuukka Turto. I'm just a random Finnish hacker, doing what little I can do with the Hylang. In addition to that, I like to play with as many programming languages as possible.
I'm Morten Linderud. I'm currently studying my bachelor in information science in Bergen. Quite passionate about open source software, hacking on stuff, and just doing development in general.
So how did each of you get introduced to Python initially?
Paul, why don't you go first?
Yeah, Python was always one of those languages that was sort of in my ecosystem, always sort of in my sphere. I started out working in PHP and Java back when I was in, probably was middle school. And I really have always admired Python, but never really put the time into really getting to know Python closely until probably around college. When I started doing a little bit more in it, and I started to explore more and more of the just insane number of libraries written for the language, and I was hugely impressed by the community. And ever since I starting to get to know Python, it's just been one step after another, and it's always just been incredibly amazing and engaging. And these days, I'm a regular at PyCon, and certainly love the Python ecosystem, the Python developing world.
Tuukka, how about you go ahead and tell us how you got introduced to Python?
Yeah, it was in the beginning of the 2000 when I was working at the Nokia, and back then we used to do everything with a Perl. And then there was this one guy who was really avid Python hacker, and we were doing an internal tools project, basically revamping the whole build tool chain. And he managed to convince us that let's write it in the Python. And back then I liked the language quite a bit and started using that for my personal project, doing little games programming and little bit systems programming with that, and rest is the history. It's probably one of my favorite languages currently.
I think I was hanging around on some shady IRC channels like 2010, 2011. And then I was like wondering, programming, how do you do that? And then somebody said, Python is a good start. So I just kind of started with that and been programming Python for my main language since then, I think, like 5 years now.
So before we get too far along in the show, can one of you explain what Hi is?
Yeah, gladly. Hi is this really interesting idea. It's sort of thrilling on a couple of different levels. It's primarily something that will take S expressions, will take this sort of parenthesis notation that's used in Lisp programming languages, and translate that under the hood into the Python abstract syntax tree. So it'll read in the data structures, the S expressions that sort of define the Lisp programming language family, and turn it into the equivalent Python code that will execute and produce the same result that you're sort of getting at with this expression code. So you can think of it like an alternative syntax for Python. Sort of what you get by doing this is you can start to look at implementing things like macros and start to treat code like data. This is a pretty interesting and powerful concept, and we just sort of wanted to explore what exactly it would look like and what exactly it would mean. And it was also really a fun way of exploring some of Python's lesser-known internals, like PEP 302 import hooks and the Python abstract syntax tree. So it was just too irresistible of a project to not engage with.
So what inspired you to create Hi initially?
In college, I had done some research work on decentralized algorithms and emergent behavior. This is sort of looking at how we can program, how we can create systems from the perspective of individual actors, rather than from this sort of top-down, logic, rule-based kind of approach, this very hierarchical, algorithmic approach to solving problems. So instead of trying to program a ant simulator from the perspective of the ground, you sort of program the ant simulator from the perspective of the ant. And by limiting how you actually define the interactions, then you're able to sort of scale up so that running this simulator for one ant is just as easy as 10,000 ants. And essentially, I was working at the Sunlight Foundation at this point. It was a couple years after I'd graduated, and I wanted to revisit some of my older research, and I was writing some Python, and I was like, man, I wish I had Lisp to write this stuff, because Python is sort of a little bit harder to do from this sort of this agent-driven programming, this sort of agent perspective. It was sort of awkward to write that in Python, but using Lisp for everything was also kind of hard because it's sort of a pain to model things. So I was wondering how exactly we could combine the two. So Hi is actually short for Hymenoptera, which is it means membrane wing, and it's stuff like ants and wasps that exhibit this sort of swarm behavior. So the name's a little bit of a nod to that original sort of creation story.
So what do you recommend as reference material for Python developers to gain familiarity with idiomatic Lisp?
Currently, we have a Hylang.org, which is currently a list of like all the core features, functions, and some sources. Other than that, you have some pretty great projects, like from Algernon. I don't know his real name, but he has projects like Idiomatic and Mini Canron implementation in Hylang, which is pretty neat. You also have this. You also can look at the source code for Hi, because lots of the core library and contrib modules are written in Hi and pretty idiomatic, I'd say.
And also outside of the Hi world, just to expand on that, because that's definitely totally right. There are a couple of sort of really popular, awesome books about other Lisp variants that aren't Hi, particularly The Joy of Closure, Let Over Lambda, and Land of Lisp are all favorites of mine.
Yeah. You also have this book called Closure Programming from, is it Chas Zebrick, I think, which is also pretty neat to read if you were interested in Lisps.
We should make a point of getting these books into the show notes after the fact, because I think that could be useful for people.
Yeah,
Definitely.
we can get links.
Cool.
Great.
So what are some of the problem domains where implementation becomes easier or more elegant as a result of Hi's Lisp syntax?
Tuka, I think this is you, man.
Yeah, it is.
Well, I think it's pretty much anything. I haven't really found anything. I mean, the thing with the Lisp is that you can, instead of just solving the problem, you can first, when you start working with the problem, you can first create the language that you want to express your problem with and solve them with. So first you create your language, and then you use that domain-specific language to solve your problem, and pretty much anything seems to work as far as I know. For example, I haven't had any performance problems with the Hylang, and I have been doing just a little bit of games programming. Nothing serious real-time stuff though, but well, basically anything.
Yeah. Also, like since Hylang is this Lisp variant, you also have this declarative and functional programming aspect of language. So it's pretty neat and powerful when working with data structures and in general just iterating over data, which is where like the declarative paradigm really shines compared to like object-oriented programming and modeling like objects.
Yeah, I definitely think Tuka was being a little bit modest there. One of his projects, Herculum, is this gigantic, really fantastic DSL for writing roguelikes in Hi. Yeah, so really, really I think the best way I've heard this described to me, and I have to laugh about it a little bit because it's so perfect, is sort of like C and Python and all these sort of like well-established and widely adopted languages are really great once you know the problem that you're solving. Lisp is really good when you have no idea what the problem is yet, because you can really alter the language to fit just right. So when you're working and you realize that your problem's actually slightly different, it becomes really easy to quickly prototype and literally change the language to fit a different problem space. So any time where you're working with a lot of unknowns or where you're trying to handle sort of this really weird corner case of computing, it's sort of where Lisp shines.
So I've got a couple of points that I want to tie back into here. So going back to your point, Morten, about Lisp being useful for doing data manipulation, I noticed that there's actually a Hylang kernel for the Jupyter project, and I'm curious if any of you have experience or know of anyone who has used this for doing any sort of analytics or data science applications.
That's a really great question. I'm not super sure of any applications because unfortunately people don't always report back all the awesome stuff they're working on every once in a while. Oh, sorry, go ahead.
There's actually, I can probably get the link afterwards, but there is a IPython notebook with Hylang doing some machine learning, linear regression stuff in an IPython notebook, which is pretty neat to look at. We also see the data sets, and the results. You can probably get that link.
Yeah, that would be great.
That is awesome.
And wasn't there that one guy who wrote that natural language program that you feed some prose into it and then it generates you poems and prosaic.
Oh yeah, the poetry generator.
Cool.
I'd forgotten about that.
Yeah, if we could get a link for that, that would be great.
There's so many really cool projects for the High.
And so given the ability to create powerful macros in Lisp, could High be used as a way of prototyping or backporting new language features in Python itself?
All these questions are just my favorite questions.
We can take it easy. Yes, we have done that.
So just to kind of prove that point, I backported the yield from operator from Python 3 to Python 2, and it basically splats out a gigantic hunk of code. And it's actually super interesting because a lot of people don't sort of know what's going on with yield from under the hood. And I sat there for like a couple hours, and I went through the CPython interpreter and took a look at what the bytecode was doing. And for additional reading, anyone out there, it is actually thrilling, and the implementation of yield from is just extraordinarily just graceful and tidy. I really appreciate the way that was written. But yeah, I backported yield from by essentially making this macro splat out a bunch of boilerplate Python code, like probably about 25 lines, that has the same behavior as yield from. It just yield from is able to remove all this redundant code to make the generators sort of talk correctly. So it's definitely possible to do that stuff. Another one that comes to mind would be probably a context manager. I haven't tried this yet, but I assume that writing a context manager in a macro would totally be doable even if you didn't have the built-in context manager operator in the AST.
So what you're saying is that by leveraging the power of Hylang, we could actually get the Python 2.8 that everybody has been clamoring for.
So long as everyone's willing to port their code to High.
One thing we have kind of been it's a kind of a stretch, but we have been sort of bragging about that Hylang is more portable than normal Python code, because in theory any High code you write should be compatible with everything from 2.7 to 3.5, I think.
Mm-hmm.
I think we skipped out 2.6 recently.
Okay.
So any High code you write should run on all Python versions with little to no modification whatsoever.
And that leads me to another question that I had is, what would be involved in porting High to run on alternate Python implementations such as PyPy or Jython or any of the others?
It already runs on PyPy, actually.
Great.
Pretty neat, because the only thing Hylang needs to be able to run on any Python platform is that the implementation have just implemented the AST module, and PyPy have done that. Jython have done that now in the recent release, but we're touching upon some pretty strange bugs last time I tried. So I'm actually segfaulting the whole compiler. So yeah, it's interesting.
Yeah, that's all completely spot on. Some of the just when I was originally doing the port to PyPy, some of the interesting bugs that we did hit are probably worth mentioning. So with PyPy, when we were doing the initial port, the AST behaved slightly differently than CPython's AST. In particular, one really terrible thing we were doing at the time was running line numbers backwards in some places, because it would be possible for the compiler to insert code before code that was written before that line, basically for stuff like imports. So if you had to force some sort of import, it would bring that import up to the beginning of its scope. Unfortunately, what this meant is the compiler would see line 35, line 32, line 33, line 34, line 35. CPython let you do this, unless you were running in debug mode, which is pretty hilarious. If you wanted to debug Python, it'd start segfaulting in a different place. But PyPy just didn't accept this at all and started crashing. And in general with Python, if you give it bad AST and you give it bad code, I mean like actual Python bytecode, it'll start to crash in really interesting ways or just segfault. So during initial ports, sometimes we'll see quirks in the sort of undefined behavior of the AST, because AST is sort of defined as platform specific. But yeah, it's already been ported to PyPy, and I'd be interested in someone doing some work on Jython. I think we were having some virtual env issues at one point. So.
Okay. An interesting thing is that in the latest release of High, if you just type list comp, it would just and with no arguments, it would just segfault Python. It fixed the master, but it's not released yet.
I gotta try that now.
You kind of brought it up in a couple of cases. You brought Clojure itself up, talking about books, and you were just talking about PyPy and context managers, various other things. I have to ask, one of the cool things about Clojure is the fact that its data structures are atomic, right? Like Rich Hickey talks about, we need to get away from place-based programming and into a more modern, I forget how he refers to Clojure. So is are data structures in High atomic and thread safe in that same way?
No, unfortunately, and it's a great source of, I wouldn't say contention, but I think everyone's generally not super happy that we're stuck with mutable objects. But we sort of solved this weird, slightly different problem than Clojure. So I should prefix this with, I'm a huge Clojure fan, and I definitely love working in it. And Clojure was a big source of inspiration when we were looking at High in the early days. But Python does this weird thing where you're not just able to call into Python. So you're not able to just do FFI, but Python code can FFI into High as well.
Interesting.
So Python can import High modules as if it was Python. And in fact, this works so well that the Python bugger, PDB, is perfectly happy to step through High code. You enter a function call and then keep hitting SSS, and then you're going through S expressions. You're going through Lisp code in your Python debugger. It's hilarious.
That's pretty awesome.
It's fantastic, but essentially High tricks Python at such a low level, at the bytecode level, that we're able to get away with murder. And I've been able to implement stuff like Django modules, and Django requires that it's able to import modules in order to use them. And this is a pretty common pattern with the Python ecosystem. And so we're sort of aiming for bidirectional interoperability. And
Right.
as a result of that, it becomes really hard to add immutable data structures, because the data structures we receive from those programs are going to be mutable. And so you start to have to be a little bit more aggressive with how things become immutable, what's immutable. And there's such a headache surrounding that. And because we don't control the runtime, because it's actually CPython's runtime, it becomes incredibly difficult to use immutable data structures and still seek this sort of bidirectional interoperability that we're looking for.
That makes perfect sense. And in a sense, I feel like I can see why a newbie like myself would have asked the question, but now I can see that the question is stupid in a way, because exactly like what you just said, you're making this alternate syntax that's built atop a completely mutable language paradigm, and so it wouldn't make. I can't even imagine how you would bridge that gap.
It's a thrilling problem, though.
One argument is essentially that you could just enable a compiler flag or something and just assume nobody will import the I code and just have immutable data structure from get-go. It will break probably if somebody imported the Python, but we could just assume that won't happen. And that would partly solve the problem. And we have been discussing that.
Okay. So if you were to get rid of the idea of it being bidirectionally usable and only take advantage of the immutable data structures within your high code that doesn't get imported into the Python syntax, then it would function properly. Is that what you're saying?
It could. We haven't tried it.
Okay, so it's a theory. It's an untested theory.
Yeah, it's a theory, and we have sort of saying, yeah, we could probably try that. It's just an interesting theory to see if it would work or not.
Mm-hmm.
Yeah, some sort of no, really, Python totally won't be calling me, and I totally accept that everything that I'm going to be working with is going to be high code. The problem becomes solvable. But yeah, I think that's probably right.
At that point, you have to question, it almost seems like high becomes something else. And it's almost like why are you actually writing code that gets translated into Python? Why are you, as opposed to just using another language or something like that? But
oh, yeah. I mean, there's a really beautiful Lisp implementation in our Python called Pixie. And if you don't need bidirectional interoperability, check out Pixie. I mean, if you don't need to import the Python modules and you don't need Python modules to call your code, yeah, go for a language that has proper scoping and immutable data structures everywhere. That's I don't think anyone would follow you. But if you need to be working really and totally embedded inside Python, I think that's where Lisp or where High really shines.
So what are some of the most challenging and interesting problems you encountered bringing an alternate syntax to the Python runtime?
Yeah, that's a good one. So I'd probably go with the interesting part about this is I think the answer is not one based on Python sort of the technology. It's not based on Python the code base, and it's not based on High the code base, I don't think. I think it's more what your expectations are when you're in a Lisp programming environment. It's sort of a testament to the last question about immutable data structures. I think people would generally assume that in a Lisp. And I think people, when they look at scoping in Python, it's certainly been talked about to death, and it's the reason why we have non-local in Python 3. But the scoping in Python is definitely not what most people would think of when they think about sort of Lisp scoping. One common technique, and this technique sort of exists because a lot of Lisp-like programming languages don't have objects, is to create a closure around a let. This is sort of called a let over lambda. It's where you return a function that's within another function, and it lets you access variables in the closure outside of yours to maintain state. So in Python, most people would say, oh, create a class for that, and then create an attribute x, and then every time you run the function, it would increment self x. In Lisp, you would create a let, and you'd have let x1, and then every time you run the function, it would do x plus equal 1. And if anyone knows Python scoping super well, this will lead to a Python scoping bug where probably unbound local error, I think, where you try to access something outside your scope before you've assigned to it. So I think that the problems aren't so much technological. I think that Python's AST was really powerful. I think using it properly wasn't all that bad. I think PEP 302 import hooks to actually do the import of High modules from Python was totally exposed and worked great. I think that enough of the compiler was exposed to us that we were able to get this done, but I think that the expectations were probably the hardest part to manage.
And so this leads into another question that I had as to if there were any particular aspects of the Python runtime or ecosystem that lent themselves well to creating a Lisp dialect to run on top of the Python VM.
Python exposes the really neat internals to Python programs that allow Python programs to sort of take a lot of control over the runtime itself. So you look at the way that PDB works by attaching itself to settrace. And Python programs are really able to access the Python VM in pretty impressive ways. So some of the very particular things that we used are PEP 302 import hooks, which were originally designed to facilitate loading from zip archives. Before that was sort of hard-coded into the CPython runtime. But after PEP 302, it was sort of envisioned that that would live as a extension written in Python that would actually do the zip file loading, so that didn't have to live in the C code. We took advantage of this. By the way, any intrepid hackers that are thinking about it, you could totally write a PEP 302 import hook that would go over the line to maybe PyPI. So if you import foo and foo isn't found, then you could just run a pip install foo and then return the module transparently to the user. I mean, don't do it. That'd be horrible. It would be ridiculous. But you could totally do it, right? That's exposed to you as the programmer. And so 302 import hooks let us search sys.path as if we were the Python interpreter searching syspath, and search for .hi files rather than .py files, and then do the import and insertion into sys modules and tell Python, yeah, totally, yeah, we absolutely found that module. You should just go ahead with it. And Python's incredibly tolerant of it. The Python AST is also just absolutely wonderful. It's a little bit hairy to work with because you can crash the interpreter in tons of really interesting ways, but it's all completely available to Python programs. And so we were able to write code, not unlike Lisp macros, in fact, because we're writing code that writes code in the way that Lisp code writes code. So the things that sort of Lisp programmers will commonly talk about being amazing about Lisp, which is the idea that code can write code, is sort of exactly what the AST module provides to Python. It allows Python code to write Python code, and you're able to use that code later by evaluating it or turning it into bytecode, or turning it cleverly into bytecode and putting it into a function's done with code object. You can sort of do whatever you'd like.
And so I'm curious as to how, sort of what level the high binary lives at, or how it interacts with the Python VM and how it gets loaded in.
So the Hi's compiler is written in a hybrid Python and Hi. The sort of core compiler is written in Python to avoid bootstrapping problems. Mm-hmm. And that takes in the sort of model, the S-expression model of the code, and dumps out AST. So it sees a form that's parentheses fn, and then the arguments to it. So it knows that it's building a function. And so it dispatches it to the function internal, and then returns an ast.functionDef. And that all goes through the input code. So it goes out to the file, it turns it into, turns S expressions into Python objects. It goes through those objects, turns it into Python AST, and it takes that AST and it turns into Python code by using the compile built in Python, and then it'll execute that. And it it lives in this sort of weird, both nested and peer position to the CPython runtime. After a certain point, Hi is totally hands-off. In fact, Hi can build out PyC files, and you don't even need Hi installed at all, really. You actually kind of do these days, but you can just run Python on the PyC. So you can think of Hi as a compiler more than a runtime.
And also, there is another language that also does the same. It's funnily enough called Dogelang. It's made by Pyos, which is a Haskell implementation over CPython, which is pretty neat as well. And it also uses the same import hooks to import Python, and I'm not quite sure if it does this bidirectionally, but it at least imports Python modules the same way Hi does.
That's very interesting. So while playing around with the Hi REPL, I noticed that it does visual matching of parentheses when closing an expression, and I'm curious what other niceties have been included in the REPL.
Yeah, that's a really great question. So the REPL was one of those things that I kind of slapped together before the PyCon talk at PyCon. I'm sorry, it wasn't a talk, it was a lightning talk. When was it? 2013, I think. And we slapped together this readline module which did paren matching, I think tab completion. I'm pretty sure it does tab completion for functions that it knows about, probably not macros though. And I can't remember if we put too much else in there. At one point I think someone was looking at colorizing the REPL with pigments. I don't know how far that got, but we've always sort of been having fun with the REPL. I think all of us kind of love a fancy REPL. So
yeah. There's also me and a guy named Farhaven have been implementing. Originally, it was a Clojure project called NREPL, which is just a REPL that communicates through networks. So you can just connect a socket with it or do it through HTTP. And it's like a standalone REPL, and you just write a client for it, like in Vim or Emacs, and you can just connect to it. Me and Farhaven essentially did this for Hi. And we're also like piggybacking on like these Vim and Emacs clients written for Clojure. So we just like connect it up with Repple, and this client just evaluate Hylang instead of Clojure. And in regards to this, we're also considering implementing a new REPL on top of this with more features, because REPL in itself just does a lot more than this current REPL.
Along those lines, I was curious about your thoughts on adding auto-completion to the REPL as a way of encouraging discovery and exploration of the High language. And also as part of that, on a previous show, we spoke with, Chris, help me with the name.
I know, I'm thinking too. Are you thinking of the guy who wrote PT Python?
Yes.
We're sorry, PT Python author. We've done lots of episodes and it's hard to remember.
Yeah. But anyway, the prompt toolkit, which is a readline replacement, I'm curious if you have either...
Jonathan Slenders.
Yes, Jonathan Slenders, if you've come across the prompt toolkit and considered using that to facilitate the Hylang REPL.
So I remember coming across that pretty recently and being super interested in it. I haven't had a chance to play around with it. But since the early days of High, one of the sort of community folk, people that have always stuck around the IRC channel is Thomas Ballinger, who was at the Recur Center for a while. And he and I are friends, and he is one of the folks behind BPython, and so I've always been interested in adding a BPython-driven High REPL to have the sort of drop-down auto-completion. If anyone out there hasn't seen BPython, I highly recommend checking it out because it's a really cool project.
Yeah, I've played around with it. It's very nice.
Yeah. I also believe Walling has BPython branch where that supports Hylang. I'm quite sure it does.
Oh man, even better.
Yeah, and I myself, I'm using just a simple stuff that you can do with the Python. The help and dir, they help you loads when you are playing with the code. Just have a look at the docstrings and the attributes.
So you mentioned docstrings. I know that the majority of my experience with Lisp has been with Emacs Lisp, and I know that supports, adding a docstring, and so I'm assuming that Hylang has that same capability and that it would compile to the dunder doc function call. Is that correct?
Yeah, that's absolutely correct. And stuff like Python's help built in will totally work on imported High modules.
Oh, cool.
Yeah, given the strong focus on documentation as part of your code, it's definitely encouraging to see that Hylang has that same capability.
Yeah, it was one of the first things I made sure were there. Yeah, I've always been a little bit of a doc fanatic. So
which Lisp variant is High most similar to and why?
There's always kind of been this constant tugging war between people that does Scheme, people that does Common Lisp, and people that does Clojure. So we have from the get-go had these like aliases, defen, which is from Clojure, and we have defun, which is from Common Lisp, etc. And the main is, I think, one of Paul Tagg's original goals was to be able to just like copy-paste Clojure code straight into Hylang and make it work.
Nice.
Not that realistic today, but it was. I think you mentioned it. So Hylang itself draws a lot of inspiration from Clojure specifically, even though we don't talk about the immutable structures. But if you're familiar with Clojure, Hylang is not that hard to get accustomed to. You got immutable structures and a few like these quirks with the scoping, but it's probably more close to Clojure than anything else, to be honest.
That's great. And as a follow-on, how does garbage collection work in High and why?
I have the most tongue-in-cheek response to that question.
Oh, go ahead. Do it.
By all means.
You can edit it out if it's too much, but it's like, yeah, well, we used to see Python PyPy runtime. So the real question is, we don't really know. I mean, it's not our problem. It's C Python or PyPy does that.
Good answer.
That's an awesome answer.
For what it's worth, if anyone's actually interested in memory, the garbage collection in CPython or PyPy, there were a couple of really great ones this last PyCon about them. So totally recommend.
Cool. And how hard would it be to port existing Lisp packages to High, like Maximo or Close?
Man, that's a tough question. Because High is so sort of built into the Python world in sort of every aspect. It hosts itself on the Python VM, and it behaves exactly like Python code. It's sort of a question of what this code's doing. I think that Lisp code is generally portable. Algernon, one of the High developers, was able to port the reasoned schemer mini Karan implementation over to High without too much problem. But every once in a while, you'll run into weird scoping bugs, or maybe something isn't implemented yet. But on the whole, if you sort of spend some time looking at it and porting, generally, yeah, it's portable. But if it's already written in a different language, I don't know. You should do whatever makes you happy. That's my philosophy on it. So whatever language is gonna keep you happy, that's what you should use. So.
What kind of overhead in terms of runtime performance and memory usage does High impose? Has this been a challenge in High's development?
There isn't really anything worth mentioning in terms of memory usage or anything like delays to runtime, because the first time you run High, it parses the whole file, and then it generates the precompiled byte files, the .pic files, and after that, there's no overhead at all. It just runs just as fast as Python does. The only real problem you'll notice is that because it's a string handling in PyPy that's rather slow. So you have this noticeable delay the first time you run a High file, because PyPy uses a little time to read all strings. But after the initial run, you don't really notice it all that much.
That's really super cool, because when you think about it, I guess when I wrote this question, I was thinking about language implementations for instance, JRuby, where there's this real sort of impedance mismatch between the Ruby object system and the Java object system, and the language runtime has to do all this heavy lifting to get the two worlds to coexist. And it seems like the way you folks did this by hacking the Python AST and import hooks, that is totally awesome. That you can basically have a Lisp in Python with almost no runtime penalty is kind of gobsmacking.
Yeah, but I think you made the comparison to the Python VM just being LLVM. You can just remove the whole syntax layer to Python, implement whatever you want, and not really have any penalties for it because of the bytecode. So, if you want, you could just do this at your favorite language. Who does not want a PHP language implemented on top of Python?
Pass, thanks.
pretty much anybody who has ever used PHP, probably.
Well, you could do it if you want to.
Yeah. So what are some of the most innovative uses for High that you have seen or created?
I really recommend just going to GitHub and just look at trending repositories under the language High, because there's always something new there. You have this project called Pineal, which is just, if you have ever seen this overtone for Clojure, which just produces sound for live coding. Pineal is just doing a live graphics in Hylang in real time. So you just edit code, you write code, and as you say the file, the graphics will change according to the code you write.
Oh, cool.
So you can have this.
That's amazing.
He wrote this for doing. I think he does it for live DJ sets, where he just DJs and then edits the graphics according to the music live on the screen. It's called Pineal, I think. You also have as I mentioned before, Algernon has Hydematic. It just goes over your Hylang structures and just simplifies it. It's based on it uses the mini cannon he also implemented to just as an example, we're currently doing a little bit of overhaul when it comes to syntax in High, and one of the goals is having Hydematic to automatically rewrite old High files into the new syntaxes where they've changed it, removing the extra braces around lets and for loops as an example. That's another cool project. But as I said, there's tons of cool projects really. It's just worth checking it out.
And you mentioned searching GitHub for Hylang projects. So does that mean that GitHub actually recognizes Hylang in its sort of language overview?
Totally.
Yep, it does.
Very cool.
That's great. Did you guys work with GitHub to get that implemented, or did somebody at GitHub just do that on their own?
I think that it was a combination of pull request and someone asked them nicely. And they're like, yeah, sure, why not?
GitHub basically uses like these open source libraries to highlight code and to detect code. So you can just like submit a pull request to their repository, and they'll just accept it after a while, and then it will just be recognized by GitHub after a while.
So what does the future hold for Hi?
That's a really interesting question. And I'm not sure there's one answer. I think that in terms of concrete Hi development, Fox sort of alluded to a little bit of a language cleanup that we're doing. There are a number of mistakes that I made early on in Hi, and we're sort of living with them. So I think our near-term goals sort of to get done by September are to clean up the language so that we can sort of have a 1.0 language interface, sort of a 1.0 standard Hi lib, and really clean up some of the problematic areas of the Hi runtime. I think that that's probably the short term for Hi's future. For the long term, I'm not sure. I've always sort of let that up to the people that are working on Hi. I think that my role within Hi is largely, so there's an Italian word for an old man who stands at a construction site with hands behind his back telling people how to do things, and it's Umeral. And so I see myself as Hylang's Umeral. I'm like mostly standing there with my hands behind my back, watching the people do the real work and saying things. So I think that asking the Hi community at large what's next is probably going to get you a better answer.
Okay. And along those lines, I noticed that there are a large number of core contributors to Hylang listed on the website, and I'm curious how you determine what features to work on, or if it's just everybody picks something that they want to work on and submits a pull request.
Yeah, it's usually people work on what's interesting to them. I've sort of come from the Debian sort of software anarchy kind of point of view where everyone's sort of driven by things that get them out of bed. And in general, someone will file an issue with some idea that they have, and we'll sort of gain a bit of consensus on the implementation, what it should look like. And then we'll start prototyping some code and get that sent in a pull request and get some feedback from the core contributors. And as soon as 2 core contributors sign off on a change set, that's it. It's in. So if there was some sort of complete overhaul and there were 4 people colluding together, that's how it would go. So we don't have any sort of long-term planning, but usually we'll have someone who sets a milestone and is kind of in charge of getting the release out the door. Currently, Algernon is working on the grand language cleanup. So most of the change sets we're accepting right now are related to that.
So are there any questions that we didn't ask that you think we should have, or anything that you want to mention before we move to the picks?
I'm super happy. Those were great questions.
Are there any ways that our listening community can help out with the project, particular areas that you think you guys could use assistance with?
Yeah, sure. I think that people playing with the language and finding corner cases and getting those in the bug tracker is just immensely helpful. Everyone's very receptive to issues that come up, and everyone sort of loves bugs. So any sort of feedback from users out there would be exceedingly welcome. I think Hi is a great way to start to get to know a Lisp because you're working with the same modules and sort of data structures as you're used to in Python, and all your old code works. So if you're at all interested in Lisp for the first time, it's definitely worth playing around with. Or if you have ideas about how Hi can be better, definitely would appreciate bugs. Bugs, testing, documentation, all the usual suspects.
Or you can just like hang around in the Hi channel on Freenode called Hi and just tell us how awesome Hylang is.
All right.
Also pretty great.
All right. So unless anybody has anything else to add, we will move on to the picks.
Sounds good.
For my first pick, I came across a Python library called Spacey, which is a natural language processing library that uses Python to make it very fast. And they actually have a page on their site called Displacey, which lets you type in whatever random sentence you want, and then it will step through how it decomposes all of the different elements of the sentence to be able to figure out what they all mean semantically in the context of the sentence. And so it's just a really cool way to explore natural language processing visually and see what's actually happening under the covers. So definitely recommend checking that out. My next pick is a novel that I just read by Helene Wecker called The Golem and the Genie, and it's a very interesting story, somewhat historical fiction. It's about a golem and a genie, one from Jewish traditional mythology, one from Syrian mythology, and they both end up in New York at the turn of the century of, in 1899 going into 1900, and it's just a story of how they sort of come to get used to living in New York City among all these humans and, define their personalities in terms of how they interact with other people and each other. And it's just very well done, very interesting book, definitely worth checking out. And my last pick tonight is going to be Safari Online, the O'Reilly subscription service that gives you access to all of the books and a number of the videos that O'Reilly publishes. So it's a great way to get access to a lot of really excellent technical content. So with that, I will hand it over to you, Chris.
It's funny with regards to your last pick there. Those guys just moved in right next door to my company in downtown Crossing, so it's kind of funny. Their office is cool. So for my first pick, I'm going to pick a documentation reader app, which I know sounds about as interesting as watching dishes dry, but this thing is really, really awesome. It's called Dash for OS X and iOS, but there's also a kindred spirit version for Linux and Windows called Zeal. And what makes this thing so amazing, at least to me, is that there is support for it in virtually every editor that exists, Emacs, Sublime, Vim, etc., to say, bring up documentation under cursor and dash. And it has doc sets for every programming language and API that is at all popular anywhere under the sun. And they just recently added this really great feature that if you own both the OS X version and the iOS version of Dash, you can actually set your iPad up as a remote so that you bring up documentation. You basically say, I want to look up the documentation for, all in Python, and it will actually bring up the doc on your iPad, which is kind of neat. So that's my first pick. My second pick is a podcast called Reasonably Sound. It's by this gentleman named Mike Rugnetta, who is the host of another pick that I'm about to pick in just a second. It is a really interesting podcast. It is all about sound and the different ways that sound, that we interact with it and that it kind of interacts with our world. And I highly recommend, there's an episode on echoic memory, which is really neat. And it's very cerebral, which is really interesting because the other pick that he hosts is kind of very different, a little less cerebral, but it's really good. And my last pick is a YouTube channel called the Pbs Idea Channel, which, again, has kind of a generic sounding name, but it's really great. It's this guy, Mike Rugnetta, and basically every episode is a topic it could be from modern pop culture, it could be something in modern society, but it is beautifully produced. They put together all these video clips and memes and everything else as he's speaking, and it's a really great example of some of the excellent content that's on YouTube these days. And that's about it for me.
So one really interesting project that I think is going to be super important for the world at large is a project going on in Debian right now called the Reproducible Build project, which is an effort to strip non-determinism in creating a binary from C code, so that multiple people can certify that a binary corresponds to source. And this lets multiple parties say, that binary definitely corresponds to the source that's being distributed, which is going to be really important as we try to verify integrity in operating systems going forward. You can read more about this at wiki.debian.org/reproducible builds. I also totally love model view culture, so definitely worth a subscription. It's a really fantastic quarterly publication focusing around diversity and tech culture. Definitely worth subscribing.
I can second that one. That's a really good newsletter there.
I have a couple ones. The first one is this old computer science lecture called SIGP, Structure and Interpretation of Computer Programs. It's available at the YouTube. I think there's a book for that too. And that's actually the lecture that I keep rewatching now and then, and that's what actually when I was trying to learn Lisp opened the rabbit hole to me.
Mm-hmm.
I had tried Lisp a couple times before, but it never really worked. But this one actually is the one that showed me that, oh, this is what this stuff is. It's really super interesting. Even if you are not into the Lisp, it's still interesting to watch.
It requires some pretty heavy math skills, though, to get all the way through it, right?
No, not really.
Ah.
Not that bad. And you can always rewatch it. And the second one, as I mentioned earlier, I really love to play with different languages. And the most recent one that I have been playing with is the F#. That is a .NET language. It's a functional language, and it's really, really neat because you can interact with the existing .NET libraries and programs. And I can throw these links on there in a moment. And
All right.
and on the F# there's this really cool, actually it's in a .NET already, Reactive Extensions. So what I'm currently trying to wrap my head around is the functional reactive programming, which is about signals and propagating of those signals and reacting those signals. It's super interesting and super different to what I have done before, and therefore kind of hard.
Yeah, the ReactiveX libraries are very interesting and very mind-bending when you're trying to sort of get your head around it, and it really fits neatly into the whole stream processing renaissance that's been going on lately. And there's actually a ReactiveX extension library for Python, so definitely worth checking that out as well.
Yeah, that's on my list. When I tried that, I didn't know enough of the RX, so it kind of failed, but
Yeah.
taking a detour and trying on the different language and then back to it.
Yeah, I first used it in the context of an Android program that I was writing.
Ah, okay. And then the third one is there's this really neat sort of ongoing event called One Game a Month by Christian Keitling. He's a McFunky Pants on the Twitter. This is basically just a challenge yourself to write 12 games in a year. So 1 game a month, and there's a huge community supporting that. And you can bounce your ideas and have people to help you out and help other people, and that is pretty neat. I think they have like close to 10,000 games already.
Wow.
Yeah, it's super crazy how people can just go and write 12 games a year, or some write even more because then they are doing those shorter challenges too. That's all from me.
Okay, those are some great picks. Morton, how about you?
Pressure. No, I'm going to be a little bit boring and pick a movie and a TV series. This should be painfully obvious what I'm going to pick, but if I say 20th anniversary of Hackers, so my pick is the movie Hackers, 1994.
It's a great movie. Nothing wrong with that.
I love
It's an outstanding movie.
I was with 8 or 9 people on IRC, and we streamed it live, and we had like this just ongoing conversation with just like quoting all the sentences. It was so fun.
Hack the Planet.
I love that movie. My second pick is just going to be the TV series Mr. Robot, because it's awesome. I'm not going to say anything else. It's just like pure awesome. I actually don't got anything else at all.
Okay, that's totally fine.
That's fine.
No problem. So, I would just like to thank all of you for taking the time out of your day, and especially Tuka and Morton for staying up at all hours of the night to join us to talk about Hylang. So,
I'm
for
at an airport. What I should have done. First people I've been talking to for 5 hours.
Oh my goodness.
So for anybody who wants to get in touch with any of you or keep track of what you're up to, what would be the best way for them to do that?
I'm on IRC and Pound High as Paultag, and I'm also on Twitter as @Paultag. And my website is pault.ag. I think generally you could just guess a website, hope for the username Paultag, and if it's there, it's probably me.
Okay.
I'm also at the IRC as Tuturto, and on Twitter as Tuturto, not as Tuturto there, because that's my cousin who got the handle before me.
Okay. Morton, do you have any ways that you would like people to get in touch with you?
Usually I'm Foxboron on plenty of IRC networks. I got Twitter on Morten Linderud. I also got GitHub on Foxboron where you can find all my stuff. That's probably the best way.
Okay. Well, I'm sure our listeners are really going to enjoy this episode, and we've enjoyed talking to you all. So, again, thank you very much, and I hope you enjoy the rest of your evening.
Yes. Thank you.
Thanks, you too. Thanks for having us.